Hello friends, welcome to follow up. Let's have a look at problem 739, daily temperatures. In this video, we are going to give you some hint on how to use monotonic stack technique. So first, we are going to quickly digest the problem requirements, and then we do the analysis and share the code. So here, we are given an array of integers called temperatures, which represents the daily temperatures. So actually you can ignore this, right? So you can just consider just as integers. So we want to return an array answer such that answer I is the number of days you have to wait after the S day to get a warmer temperature, right? So if there's no future day for which that's possible, we're going to assume that answer I equals to 0. So here we have 3 examples. So example 2 and example 3 are very special because these 2 lists are strictly increasing. And then the next day will be larger or have a warmer temperature. Therefore, for the first n-1, so here is 3, right? So this will have 1 because the next day will have a warmer temperature. However, for this last element, because there's no right element, so we're going to have a 0, right? So similarly here, we have 2 1s, and then you have a 0. So these 2 examples are very special. Well, for the example 1, it's sort of the generic case. So if you see 73, right? So the next is 74, the next is 75. So this 3 actually forms a monotonic, strictly increasing subsequence. So in this case, the first 2 are for sure to have 1, 1. Well, for 75, the next larger one is 76. So the index difference is actually 4, right? So we have 4 here. Then for 71, so the next larger one is 72. So we have 2 here. And then for 69, 72, 76. So this 3 forms again monotonic, strictly increasing subsequence. So we have 2 zeros, 2 1s. Then 76 and 73. Actually, this, if you regard it as a sequence, is decreasing. So we have 0, 0 because no future temperature is larger, right? So this is example 1. So now the constraints are the following. The temperature or the list has a length bounded above by 10 to the power 5. So this is a very, it's a decent large number, right? You cannot do brute force. For example, for each element, say this one, you do a linear scan afterwards, right? So to check all the elements behind and then find the strictly large one. So this is not very time efficient. So the temperature is in this range. But for this problem, in order to get the larger number, we don't actually need to think too much about this this assumption, right? So that actually does not matter towards the logic. So with that said, we are ready to do the analysis. So here, actually, we are going to use a very routine technique to solve this problem, the so-called monotonic stack. So basically, we want to maintain a locally monotonic stack. So in this problem, we are going to maintain a locally increasing stack. So here, to understand and practice more monotonic stack problems, you can actually check out the monotonic stack playlist in our channel. So this channel contains a bunch of problems from LeetCode. So here, actually, we want to give 2 hints to on how to come up with this solution. So here, actually, you see we want to find the next larger temperature. So you can think of that the monotonicity will play a role. First, if you look at example 2 and example 3, so for strictly monotonically increasing list, right, the next number will be the larger one. So for the first n-1 element, you're going to have 1s, right? The last one is due to the fact that there's no right element, so you have 0. Another extreme is that if you have strictly decreasing list, for example, this one, 50, 40, 35, 30, then each element there's no future larger element. Therefore, so each one corresponding to zeros. No matter what, the last element corresponding to 0, right? Because there's no right. So here, actually, for the second one, what if we append a high temperature? For example, I append 70 here. But if this index is 3, right? This index is 4, right? So this index is 3. If you pop this one, you get index. Let's see, I use a stack to store the indices. Then this will have index 3. This has 4. So 4 minus 3 is 1. You get 1. So this have index 2, and also this is smaller than this one. You are going to get difference that is 4 minus 2, that is 2. Similarly here. But if you append a larger one, 80 before, so you will not have any element larger than 80. You cannot pop anymore, right? So that this second example actually is very suggestive for the use of monotonic stack. If you have practiced quite a lot of such problems, so when you see this pattern, then you actually should react to use or resort to monotonic stack trick. So with that said, we are going to look at the code directly, and then we can print out the result or do a walkthrough. First, for convenience, I changed the temperatures to be T just for convenience. And then first, let's get the length, right? So, and then what we're going to do, I'm going to use a result. So this result will have length n, right? And then I'm going to use a stack. So this stack is for tracking the indices, right? Store indices. This is the locally monotonic stack. So now we are going to iterate over the temperature, right? So basically for I in range n, right? So we know the current day temperature will be T of I, right? So then if you have such situations, you keep pop from the stack, for example, for indices, right? And then you compare the difference of indices. So basically it's something like, well, stack. So if stack is not empty, so you can pop, you can check monotonic relation, right? Well, stack -1. If the corresponding temperature is less than the current temperature, that is T of I, right? If this is the case, so the previous index, let's call it previous I, would be stack pop, right? Then, for example, here, let's see, I store some indices 0, 1, 2, 3 corresponding to 30, right? And then I have I equals 4, right? Then I pop index 3, right? So index 3 will be previous I. Then for this index, so I'm going to set, result at previous I will be current index 4 minus the 3. That will be 1. And then we continue pop. So we have previous I equals, so after we pop this one, we are going to have 2, right? So the corresponding element is again less than 70. So we're going to set result 2 equals 4 minus 2. That is 2. So we continue until the stack is empty or we met a larger temperature, right? So this is the logic. So this condition is standard. I would say standard monotonic stack check condition, loop condition. Let's see. So once you have this, you get a previous I, and then we just do this, right? So we set result I equals the current I minus previous I, right? So that's the case. So now if we exit this while loop, either stack is empty or this condition is violated. For example, I met a larger one. So for sure, for example, you have if you have 100, right? Then you, of course, you need to adjust the indices, but just to demonstrate the idea, Then you have 70. You cannot pop anymore because 70 is not larger than 100. You cannot set the index, right? So now after we exit this while loop, so we should append the current index to the stack. So how do we understand this? So you can think of the starting, right? If you have index 0, so this stack will be empty. You have nothing, right? You need to add this current index to the stack. So this is the legitimate. This is a very easy to digest, and why. This also gives you a hint why you should do this. So once you've done this, actually you're going to finish. So you just need to return the result state. So this actually forms a full solution format to this problem. So you can do a test. Let's see. This is not right. So let's see. Well, stack and stack -1 is less than. Yeah. So now what we want to do? Press I. So yes. Let's see. So append I, result I equals, let's see, it's less than ti, right? Let's see, what's the problem here? Let's see, in range n, well, stack, then t, stack -1, right? It's less than ti. So we're going to do pop and then results. Oh, so here we set wrong. This is the previous I, right? So now let's do the check. Yeah, it passes one example, but this example is very special. Now let's look at the first example. Yeah, it passes all the first example. Once we passed one of the example 2s or 3 and then example 1, then we should expect it passes all the cases. Let's submit first. Yeah, it passes all the cases. But if you are not sure, you can actually print out each of the temperatures we set, right? So for example, let's print, so let's use f string. So current index, that is I, and the current result state. Result. Now let's use this one to test, right? So at index 0, you have nothing, right? At index 1, you can set, oh, this 74 is larger than 73, so you get that is 1. And 75, you get 1, 1. And 71, you still get this 1. And then for up to this index 5, so this 0, 1, 2, 3, 4, 5, right? You match 1 that is larger than 71, so you get 71. You also get 1 for this 69. So then you can look at 76 is larger than 72. You set this one, and then the last two. So no, this is decreasing. So you get 0, 0. Yep, that's basically about it for this specific problem. So you can actually check out these two examples. They're actually similar. So with that said, that's basically about it for this video. So thank you.